Okay, so in this video, we are doing the second half of the notes for 8.3. So again, we have gone through and done the first section of these notes on area and perimeter of the triangle, and now we are going to do just the second page of this, and you can work on your homework for the rest of the hour once you've completed this video. So the first thing we're going to talk about that we are going to need in these next two sections, or these next two examples, I guess, is the distance formula. And this is a formula that we saw at the beginning of the year. I still have people that struggle with this formula, which is why we do kind of bring it back at this point to review again. But the idea with the distance formula is that you can find the distance between any 2 points on the coordinate plane if you use that formula. And it works like slope. You have to label your 2 points. So for the first review example, it says find the distance between the following pair of points. So again, every point has an x value and a y value. I like to write these first. And then I like to classify the points as point 1 and point 2. With that, I write subscripts by those variables, and then it corresponds with the subscripts and variables in the formula. Now again, this is something you need to organize and write out the equation. So the distance between those 2 points is the square root of a big old quantity. And then I have to go through and plug in my different values. So x2 is -3. Then you subtract x1. Be careful, I'm subtracting a negative. So I need to use parentheses because that will be addition here in a second. I then square that value plus parentheses y2 -8 minus y1. That is just a regular 6, so I don't need the parentheses on that. But you can write minus parentheses 6 if you want. Then I square it. I suggest just simplifying this in your head, at least to start, because you see a lot of mistakes on these that are just calculator errors. So the distance is equal to the square root of. Then I want to simplify the inside of those parentheses. So I have -3 minus -2. That is equivalent to -3 plus 2, or -1 quantity squared, plus parentheses. -8 minus 6 would be -14 quantity squared. Now, if you want to use your calculator and parentheses, I think less mistakes would be made because, again, these are the values that I usually see errors on. So the distance is equal to the square root of -1 squared. So -1 times -1 is +1 plus -14 squared. -14 times -14 is positive 196. So I need the square root of 197. And then when I do the square root of 197, let's see what I get. So you can put it into your calculator, and then you can use the little arrows above the enter sign. So D equals 14.04 if I round to the nearest 100. So again, just to review on that, but you are going to need to use that distance formula quite a bit on the following two problems, and you really have to know that we're getting the accurate value because we're finding the perimeter that is fully reliant on knowing the distance between two. Okay, so for example B and E, it says graph each of the following triangles, then find the perimeter and area of each. And I do give you a diagram where you can plot some points, you can draw the actual triangle, and then some workspace to find the perimeter and area. The main thing you need to remember for the perimeter is that you need to add up the length of all sides of the triangle. That is how you get the perimeter, and it's measured in linear units. And then the area, you need the base and the height, and then you do base times height divided by 2. So let's start by first going through and plotting these points. So B is located at -4, 2. So I need to go left 4, up 2. I am going to label that with letters just to keep it organized and so that I know exactly what I would be looking at as the grader of this problem. E is at 5, 2. So I need to go right 5, up 2. And F is located at 5, -4. So right 5, down 4. Again, I'm going to label those with their capital letters and then connect them with straight lines. Okay, now we can go through and find the perimeter. And what I'm going to do for this, again, organization is key. I'm going to write out the different sides that I need to find so that I can fill them out. And then I will be able to add those up to the very end. So I wrote out TE, I'm going to find that length. TF, I need to find that length. DF, I need to find that length. And then once I know that, I can find the perimeter total. So for DE, I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9. If you have a line that lies directly on the coordinate, like D does, then counting it is the fastest way to find its length. EF, similar process, 1, 2, 3, 4, 5, 6. Again, count the total boxes. And then you'll notice where that distance formula comes back in. So we cannot merely count the distance on DF because it is plotted diagonally on that coordinate. It is not laying perfectly on the grid itself. So for that, I'm going to use the distance formula with point D and with point F. So what I think I'm going to do is just label, x1, y1 for D, x2, y2 for F, and then I can find the length of DF using that formula. The square root of, use the formula above on your page. So I have x2 minus x1, so 5 minus -4, quantity squared plus parentheses, y2 minus y1, so that would be -4 minus 2, quantity squared. Then I need to simplify each of those values. So if I go through, I have the square root of, let's see, 5 plus 4 would be 9 squared, plus -4 minus 2 is -6 squared. And I can simplify that. Square root of 81 plus 36. And I don't know what that is off the top of my head, so I can't figure that out in the calculator. So it's the square root of, being the square root of 117, and then I want that as a decimal 10.81. I'm going to go to the nearest hundredth on these. Again, if I don't specify tenths or hundredths. So 10.82 is that perimeter. Again, I rounded that up to 816, so the 6 rounded to 1 up to 2. And then the actual perimeter I need to get by adding all these values back together. So at the very end, I can go through and say, okay, what's the perimeter? It's going to be 9 plus 6 plus 10.82, so 25.82. And we were told at the beginning of the problem that the grid is in yards. So for the unit on that, it would just be linear yards. Now, actually on this problem, the area is a lot quicker to find than that because we do know essentially the base and the height. And you might be looking at this and think, well, where's the base? Like there's nothing on the bottom that's easy to count. But remember, if you flip this entire triangle upside down, you could have a base and a height that would be DE and TF. And so for the area, this can function as the base. It is parallel to the ground. This can function as the height. That would still be fine. So I'm going to assume or kind of count the base as 9, the height as 6. So the area is going to be base times height divided by 2. I can figure out what 9 times 6 is, 54 divided by 2. And then when I divide it by 2, I get 27. The unit on that, again, we're in yards, so it's going to be yards squared because it's here. Okay, if we look at the second one, it is definitely a little bit more tricky. So let's start out by graphing it like we did before. So A is located at 4, -2. B is located at 0, 4. And C is located at -3, -3. So here is this triangle. And I hope you are going to see why this becomes more difficult because we cannot count any of these measurements, okay? So since we cannot count any of these measurements, we are going to have to do the distance formula for every single one of these, but I'm going to do it with you, okay? We're not going to freak out. We're not going to turn off these. I think I'm going to split the perimeter box into 2 sections just to help keep it a little more organized because we do have to find the value of AB, BC, and AC. So we're getting a lot of practice with that distance formula. Now, I think I'll do this with color coding. So when I find AB, I'm going to use X1, Y1, X2, Y2. Again, when we find different side lengths, we will have to adjust where X1, Y1, X2, Y2 ends up. But for that first one, I'm going to do it in the purple color. So I have the square root of 0 minus 4 quantity squared plus 4 minus negative 2 quantity squared. So then I just went through, followed that formula with the points that I had labeled. Negative 4 quantity squared plus 4 plus 2 would be 6 squared. And I can simplify that. So the square root of negative 4 squared would be 16 plus 6 squared is 36. So 16 plus 36 gives me 52. So I need the square root of 52 as a decimal, which is 7.2. So again, this is going to take a second. We have to do this 3 times. Just wait to see the area. That gets a little crazy as well. But with this one, since they're all diagonals and not just on grid, we are going to help each one. So my suggestion is pause the video, try to find the lengths of BC and AC, and then watch again to make sure you got them. Okay, so hopefully you paused the video and did what I just told you to. If not, write down what I'm writing right now. So I need to find the distance between B and C. So again, I'm just going to label my point. It doesn't matter which point is point 1 and point 2, but just make sure you have X and Y in the right spot, and you should get the same length regardless. So I'm going to do the square root again. I'm doing this in orange, so kind of color code. And I would have X2, negative 3, minus X1, 0, quantity squared plus, parentheses, Y2, negative 3, minus 4, quantity squared. Then I can go through and simplify that. So negative 3, quantity squared plus negative 7, quantity squared. Simplify that again. Are we feeling better with the distance formula? Hopefully we are. The square root of 9 plus 49. Remember, even if you have a negative in the distance formula, when you square negative, it turns positive. So I'm going to have the square root of 58, which gives me what, a decimal? Oh, and I did say I was going to go to the nearest 100. So let me actually do that. 7.62 is that one. And then on the length of AB, I have 7.21. So I can add that on here. Sorry about that. Write it down. Good job, but that will affect our final answer. I use some in hundredths and others not in hundredths. Wrong, you get all messed up. And then for the last one, I'm going to do AC. I can focus on green color. So between AC, I have X1, Y1, X2, Y2. I really do suggest you erase and relabel. Keep in mind, that's how you're going to get the right answer. So I'm going to do square root of X2 minus X1, quantity squared plus, parentheses, Y2, minus Y1, it's minus a negative, so I write that parentheses. If you want to go straight to addition on that, that is fine as well. Then I can simplify that part, so I have the square root of negative 7 squared plus negative 1 squared, square root of 49 plus 1, because negative 7 squared is positive 49, negative 1 squared is positive 1, so I have the square root of 50, which I need to add to that. 7.07. Now, of course, the perimeter is the sum of all of these. So that's what I'm going to do very last, and then I can label it. So 7.21 plus 7.62 plus 7.07. I get 21.9, and our original grid was in inches. So that is going to be my answer. Now, the area is challenging, and the reason that the area is challenging is because we do not have enough info to the area with the formula. We would have to figure out what the base length is. The base on this is not parallel to the ground, so we have to find a way of making that triangle parallel to the ground or figuring out that length. But then, if that were parallel to the ground, we would then need the perpendicular height, which again is going to be a little bit challenging to find. So there is actually a much easier way that mathematicians can probably find the area, and that is where we're going to end today, going through that process. So here's the idea with area. If you have a shape like this that's a little bit awkward, what you can do to find the area is you can go through and find the smallest, I guess, rectangle that triangle fits in. So I'm going to go around that triangle and draw a rectangle. It could end up being a square, but it just has to be a rectangle that fits that triangle into it. And if you see, the way that I drew this, it perfectly matches the coordinates. So it's just going straight over that grid, but there is a point on all sides of that rectangle. So you don't want to make the rectangle any bigger than necessary. But here's the idea. If I knew the area of this rectangle, and then I took away this triangle, and this triangle, and this triangle, I would have the area that I was looking for, which is the area of the triangle. Now, we haven't explicitly practiced this, but I think you guys can see why that would work. So again, if we have this bigger area, but then we took away the parts that we do not want, we would be left with the parts that we do want. And it sounds like a lot of work. I actually think it's less work than finding the perimeter that we just found. So the nice thing is we can find the area of this rectangle very quickly. The way you find the area of a rectangle is just base times height. And the rectangle that we created is 1, 2, 3, 4, 5, 6, 7 across the top. 1, 2, 3, 4, 5, 6, 7 across the side. So yes, it is in fact a square. And it has an area of 49 units squared. Actually, it's so the entire rectangle that we created is 49 inches. If we can take away each individual triangle, so this triangle and this triangle and this triangle, you can subtract those away, and then we would know the area of the 3 triangles as well. So again, that sounds a little bit scary, but remember, when you have a triangle, the area is base times height divided by 2, and we are now able to count the area of these triangles because the triangles we created are on that grid. So the first triangle is 1, 2, 3 by 1, 2, 3, 4, 5, 6, 7. So 3 times 7 divided by 2. That's going to be 21 divided by 2, or 10.5 as the area of that first triangle. 3 times 5 divided by 2. Okay, then I can do the next one. So on the next triangle, I have 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. So 4 times 6 divided by 2. That's going to give me 24 divided by 2, or 12, or that next triangle. So again, that is the pink triangle. And for this pink triangle, it has a height of 1 and a width of 1, 2, 3, 4, 5, 6, 7. So I can do 1 times 7 divided by 2. So 7 divided by 2 is 3.5. Now I know all of those triangles. And again, we're going to take the total distance of the rectangle, subtract the parts we know, subtract 10.5, subtract 12, and subtract 3.5 to get the remaining area of the 3 triangles. So that is 49 minus 10.5 minus 12 minus 3.5. I got 23, and it's going to be inches squared for that area. So again, that one was a little bit more complicated. I honestly don't know if there are any like that on your homework. If there are, though, go ahead and try it out. But that whole idea of finding the area via subtraction is something we're going to see the rest of the student as well. Hope you guys are being good, and please complete your homework.